Hello, hello.
This is Kurt. He is a communicator here at Kennedy Space Centre. Kurt, just before we begin, if I could just ask you a bit about yourself.
Certainly.
If you could just tell us how long you've been working here and what your interests are.
Certainly, yeah. You know, I've been here for about a year and a half, and I've enjoyed every second of it. I come from a long line of people who designed, flew, and jumped out of airplanes for a living, so I'm pursuing that as well.
Absolutely.
And, I took my first job in aerospace almost 11 years ago. I was refueling airplanes on the flight line in my little airport in Idaho, and I got in trouble for telling stories.
Oh, okay.
So here I am.
You're in a good job then.
Telling stories for NASA, yeah.
So,
it's a heck of
are you a
job.
space nerd?
I am a space nerd through and through.
So this is a good job for someone like yourself.
It's the best job, absolutely. Yeah.
So you've been working here a year and a half. Is there any one thing in Kennedy Space Centre that it just you love more than anything else?
You know, probably Space Shuttle Atlantis. That is the object that I've studied the most. And by the way, this visitor complex is the only place in the world where you can see a real space shuttle orbiter and a real Saturn V rocket in the same day.
Yeah.
Which is quite a unique place.
Absolutely.
It's a perfect place for me.
And this afternoon, hopefully, if things go to plan, we'll be going round to Atlantis. And if you haven't seen Atlantis, it will blow you away. It really is.
She's been in space 33 times, so there's really not something to be missed.
Yeah. Well, where we are today is called the Rocket Garden. I'm just going to ask Kurt if he would like to take us on a short tour, because there is a lot of interesting bits and pieces here that people come and look at, but maybe not necessarily know what everything is. So, Kurt, we're in your hands.
Absolutely. It'd be a privilege to do it. So follow me into the rear part of the garden here. Our story really starts back there with the Juno rocket. It's the white one with the UE on the side over here. Back in 1955, President Eisenhower announced our cooperation with a program called the International Geophysical Year. It was a big effort all around the world, lots of countries getting together to learn more about planet Earth. And the U.S. contribution to that was to try and put a scientific satellite up by 1957. So we were gearing up for that. And of course, you know the story. Guess who beat us to the punch? The Soviet
Ruskies.
Union. That's right. So that embarrassed the U.S., but we continued forward full throttle. And we launched our first satellite on the top of a rocket just like that, the Juno rocket. You can actually see the Explorer 1 satellite on top, that little pencil tip up there. That is America's first satellite. It's a tiny thing, but it did big, big science. It carried a Geiger counter, which measured radiation on orbit and confirmed and discovered the existence of the Van Allen belts. If it weren't for those magnetic belts around the Earth that deflect harmful radiation from the sun, we certainly wouldn't be doing a rocket garden tour out here today.
There'll be no iPhones
there would
for a
be
start.
no life on planet Earth. So big science in a tiny little package.
And what year was that again, Kurt?
It launched early 58, I want to say.
Okay.
Gosh, too many dates in my head.
Yeah.
But in 61, I know that date for sure, Alan Shepard would climb aboard this Mercury Redstone rocket just like that. The one with the black and white stripes there.
If I could just move a bit into the
Certainly.
shade and hopefully get... There we go.
Al Shepard would become the first American in space on the shoulders of that Mercury Redstone. He would launch up into space and splash down about 300 miles behind the camera here out near the Bahamas. There was a 15-minute flight out there to the Bahamas. Sounds good to me. It's a lot faster than the cruise ships. But after that short flight, President Kennedy challenged the U.S. to put a man on the moon and return him safely to the Earth by the end of that decade. So we had from 1961 to 1969 to figure out how to get to the moon. It was a big challenge. Some people at NASA out here said, wow, Mr. President, you want us to go 250,000 miles away to the moon. We've only gotten to the Bahamas so far. It's a big challenge. But we started forward on that path. And from that challenge, we built almost all the stuff that you'll see on your bus tour here at Kennedy Space Center, the big launch pads, the big vehicle assembly building. If it weren't for that moon challenge, this place right here where we're standing would still be a swamp. Mm-hmm. We'd have to be standing here in a boat. Of course, our next big achievement was launching launching John Glenn on this Mercury Atlas here, the shiny one. He went up for 3 orbits of the Earth, and while he was there, he did an important science experiment. He had what looked to be a big toothpaste tube, but it was full of applesauce. He squeezed it into his mouth, and big science news, folks, You can swallow in weightlessness. That's what the Mercury program was really about, proving to the medical community that we can survive in space.
Yeah. And there's those small steps.
It was small, incremental, one thing after another. The next big goal, after we've proven we can survive, was to learn how to work in space. And so we did so on the shoulders of that Gemini Titan II rocket, the big tall one there. That little Gemini spacecraft up there looks humble, but it was so maneuverable. It was a pilot's dream. And it had to be, because the big goal of the Gemini program was rendezvous and docking that Gemini spacecraft with our Agena spacecraft on the top of this Atlas Agena rocket. Both of those ships were going around the world at 5 miles a second. For the Gemini program, we set lots of altitude records. We did our first spacewalks and our first long-term space flight of 2 weeks. So I'll invite you, if you'd like, to sit with me in the mock-up of the Gemini spacecraft for 2 weeks, and you aren't allowed to leave. Okay, it's like camping, but you can't leave the tent. Very close quarters there.
And of course, all the work that was carried out by Gemini, if it wasn't for Gemini, there'd be no Apollo.
Yes, all the work that was done in Gemini was really working toward Apollo. There were lots of complicated jobs we had to learn. But there's our Gemini spacecraft. So you can see, we won't let you sit there for 2 weeks, but when you come and visit, you can imagine what it might be like to, really rough it. Yeah. Like Jill.
And I think people don't realize just how small these capsules were.
Absolutely.
So we'll just quick look
this
in
is
just to see.
It's a bit of a low fidelity mock-up, but it does give you an idea of what it might be like. It's quite small, especially as somebody of my stature. I'm 6'4".
Yeah.
I would certainly not have been allowed to do this, during the gym.
I was going to say there's two of you sitting in there,
yeah, right next to each other. So it was like, Jim Lovell, after he flew in the Gemini program for 2 weeks, described it like sitting in a stall of a men's room next to his buddy. So,
I'm sure it had its own unique.
Certainly. And then in the back of the rocket garden here, we have the beginnings of the Apollo program. We have a Saturn 1B laying down here. It's the real thing, and this one actually went out to the launch pad several times as a rescue ship, but it was never flown. But it has been out on the pad.
And of course, in the Saturn V Center, you have
we have a real Saturn V rocket. Yeah, and I tell people that come here into the rocket garden, a lot of people say, "There's the big moon rocket."
Yeah.
Well, the Saturn V moon rocket is almost 3 times bigger than that.
Yeah.
So it's enormous. You'll see it later. We have an engine, however, from the Saturn V. The F1 rocket engine is the most powerful rocket engine that we've come up with so far, and probably ever. Just sitting right there is enough power to lift 1.5 million pounds up off of the ground. And the moon rocket had 5 of those things. So
wow.
Really a lot of power. And you'll be staring down the tailpipe of all 5 of them later on in your tour. So it's really quite impressive.
Yeah. And all the rockets here, are these real rockets? Or?
These are all real rockets except for the Mercury Atlas rocket over there, the shiny one there. That we had a real one, but it became a bit decrepit over the decades. It was safer to bring the real one down and put up that fiberglass mock-up. But all of the rest of the rockets are real. It's the real stuff, and so is Atlantis in the building.
That's
and
right.
So is the Saturn V that you'll see. It all should have flown. Yeah.
Excellent. Kurt, I don't know if you want to. Do you have a Twitter handle or anything?
I do. Actually, I have a website, projecthabu, HABU.com. That's where I post my personal aerospace stuff. And should definitely mention the website of Kennedy Space Center's visitor complex. This is, to get the information to visit here, it's kennedyspacecenter.com. That's where you can find all the various experiences that we have. You could come visit, but we also have our astronaut training experience where you get to train,
that's right.
Alongside some of the equipment that the astronauts used and meet a real astronaut. We have an astronaut here every day and lots of various specialty tours, like going inside the Launch Control Center and various things. So we really have a lot to offer, all at that website, kennedyspacecenter.com.
So if you have any questions, you know where to go to?
That's right, that's right.
Kurt,
it's been a privilege.
Yes, I want to thank you very much.
Happy to do it.
It's been a great start to the day, and who knows, we might see you before we're finished here.
Excellent, I'd love that.
Thank you, Kurt.
You, enjoy.
Thank you, bye. Well, there we go, that was the rocket garden. I'm just going to put you on hold for a moment, and then we will be back later and I'll do some more exploring.
Wait, so you want to reduce the CO2 buildup?
We need a better safety margin. The crew can tolerate a short-term increase, but...
Engineering? Morning, Betty. What, right now? Building 36?
I didn't even know there was a building 36. Must be important. Everyone's here. We got propulsion, aerothermal, flight dynamics.
Anyone know why we're here?
For this. Good morning. We're going to create America's next spacecraft. It's going to launch like a rocket and land like an airplane, and it's going to be reusable.
Can't do that with a rocket.
It's not a rocket, it's a shuttle.
Now it's time to go to the next step. From sketch pad to launch pad. Going to the moon was a camping trip. Now our job is to work and live in space. This vehicle has to do something that we have never done before. Perform 4 key tasks and be able to do them over and over again. There is nothing easy about putting a ship back up into space, let alone a whole fleet of ships. But first, let's talk about the launch. We have never designed engines and vehicles that can be reused. But we will, and once we're in orbit, we go to work. We want to take all kinds of cargo up there in addition to the people. Science labs, satellites, even the space station. And when all the work is done, we gotta bring everybody back home. All right now. Country's waiting. Let's build ourselves a space shuttle.
It's too big, it's too heavy, but we're launching one spaceship on the back of an even bigger one.
What if we split the booster into its pieces? Rockets, fuel tank.
It's supposed to be reusable. How do we get all those parts home?
What if we just throw the fuel tank away?
We're writing all new processes, procedures, manuals. We've never had to reuse a ship before.
We're also going to have to build some really big garages.
Sir, what if she lands somewhere other than Florida? How'd she get back here? It's a glider.
Buy her a plane ticket home.
Ablative heat shields are heavy, and they burn up on re-entry. We need a more reusable solution. Silica foam tiles, thousands of them, fitted together in one lightweight, reusable heat shield.
Another holdup with the engines? Tell me some good news with the tiles.
The heat shield bond keeps failing. The tiles keep falling off.
So another delay. How long? How long?
1.5 to 2 years.
Well, this is going to be fun to tell my boss. Everybody get back to work. I'll let you know. When they come home.
The President's message said you go forward this morning on a daring enterprise and you carry the hopes and prayers of all Americans with you. And astronaut John Young, the commander of the mission, replied, "That's a right fine speech. We sure appreciate it."
Endeavour Houston, we see a nominal MECO, ohms 1 not required. Welcome to space.
the Colombian Challenger astronauts.
water from reaching the surface. The result? The collapse of a huge fissure. This is what Peruvian fishermen call El Nino, the Christ child, because it typically comes around Christmas time. Even though the name El Nino has this local origin, its impacts can be global in extent. An El Nino usually occurs about every 3 to 7 years, and they aren't all the same. Some are much stronger than others. Really strong ones occur only infrequently, perhaps every 10 to 20 years. When a strong El Nino occurs, it can disrupt ocean conditions throughout the entire Pacific, which impacts weather around the globe for more than a year. The weather effects of each El Nino can be a blessing or a curse for different continents around the world.
I didn't do it. When we were here in November for the Goes-R launch, we got a special Science on a Sphere show, which is cool. The images there, you're saying they're not from Goes-R, but the Goes-R's Go 16, as it's now called, has just released its first set of images, and they're beyond high definition. You really do need a good look at it to see the detail that's involved, and they can update, I think it's every 30 seconds. So Alexa and Noah can get a almost real-time view of what's going on in terms of the weather. And it shoots in 16 different wavelengths, so it's not just visible weather we're looking at. Now looking at moisture, heat, rainfall, temperatures. Let's grab a seat. Okay, this is something else I want from my house. A giant sphere, which you can project images onto.
Talk a little bit about planets. What's actually on the globe right now is the Milky Way galaxy, which we belong to. It's made of around 2 to 400 billion stars. That little red line that you see around the center is called the celestial equator. And then there's clouds of gas condensed into stars. Some material creates an object that orbits the developing star. Our own developing star is the sun. They've also called that the yellow dwarf star. It contains 99% of the material that makes up the solar system, which is mostly hydrogen and helium. Those little red spots are solar flares. We get our energy actually from the sun, directly or indirectly. And Earth is 93 million miles away. Anybody know how long it takes to get here?
I do.
8 minutes. That didn't, 8 minutes, that's pretty quick. Somebody keeps saying light years, like, no, not light years. Next door, your very first planet doesn't even look like a planet. Mercury is so close to the sun, its atmosphere has actually been burnt away. It's a place that looks more like the moon. The temperatures are very hot there. They get well up to 800 degrees Fahrenheit, and actually you get really cold to minus 390 degrees Fahrenheit. Mercury travels around the sun in just simple little 88 days. Now, what the scientists do to be able to study it, they put a little color with it. And if it actually happens to look like white or light blue, they'll call it a young crater ray. They're saying that it's been freshly impacted, most likely by comets and asteroids. The coloration gets to medium to dark blue. That's just the geological unit that they'll use to study Mercury's crust. They call that the low reflectance material. The Claris Basin is one of their very notable features, which is probably right about now, a big round looking spot here. Spot towards the top. It'll kind of look like an eye in the middle of it. That is the Clarence Basin. Got a little spot here at the top, and look like a little eye. That's the Clarence Basin. Now Mercury is a place that, we can study, but we can't visit. It's too hot. Venus is actually even hotter. Average temperatures there are 863 degrees Fahrenheit. Travels around the sun about 223 days. Now, we see Venus a lot in the sky. It's the morning or also the evening star. It has a very unique feature that makes it different than all of our planets, including us. The planets will orbit around the sun. Some of them take many, many years. Well, Venus does orbit the sun. It goes the other way. It goes the opposite direction. I don't understand why it does it.
Venus is mad.
It does definitely makes it what it's very unique. Russians actually were capable of putting something on the surface. Actually, these two objects were called Venera 13 and 14. They made it 90 minutes each. Nothing should have lasted a minute, well over 863-degree temperatures. So that's kind of cool. So we are going to study these planets with different types of satellite probes. We can't set foot there. The Earth is a big blue marble.
Yay.
Even when you're on the International Space Station, is what it looks like in space. Until it's at 23.5 degrees, that's what gives us seasons. We're about 8,000 miles in diameter. So we look around the world, the nighttime lights gives us a chance to kind of tell how populated we are. I mean, when I was a kid, we were just millions of people. And today, it is billions of people. Close to somewhere about 8 billion. So the more the lights, the more people in this location, especially in China, India. Should already billions of people already live in China. Lights come out of Europe, a little bit here and there in Africa, depending on where it is. You gotta remember, there's not lights every location. We have deserts, we have forests, we have mountains. You've got lowlands, you have highlands, you've got rivers, lakes, ponds, or oceans that keep us separated. But there is a reason we should be reusing and recycling this planet. We still got lots of generations still behind us. In the U.S., there's a lot of lakes on the eastern coast of the middle of the country. There's another big mountain range in between us and the west coast. We have a mountain range even on here on the eastern side. On an average day, there's 5,000 planes flying around the world, traveling all different locations. About the only place they don't go is down in the South Pole or Antarctica. Could you imagine being an air traffic controller? No, it was daytime or nighttime across the North Pole a lot. And a lot of air traffic comes out of Europe, no doubt about that. Here, Europe and the U.S. And there's plane traffic coming out from everywhere. Some might even actually float into Orlando, Miami, and on into Atlanta, New York, Washington. Chicago, Houston, Denver, LA, San Francisco, San Diego. I think this looks like a pretty tough job when you think about it. We're also the first planet close to the sun that actually has a moon. 12 men got lucky enough to walk on the moon's surface. That really was intended for 14 men to make that happen. Apollo 13 is a very accurate movie, I can tell you that. I know you've been on Saturn V, we just had this map that showed the landing spots, but this one gets to show the surveyor missions and also the landing locations. Places that we were looking at, we wanted to set foot on. But to think about it, late 60s, early 70s, we made it to the moon with our technology. That's also what changed our technology quite a bit. I'll just move on to the shuttle program. Moving on to another generation now too. Well, someday we're going to go back to the moon with Space Launch System. There's a nice model of this rocket down at the other end of the building. Put 4 people in that Orion capsule. You can see outside there. Nice model too. Better than our old model we used to have. But we have to do this unmanned first. We know maybe 2018 or 19 spent that rocket to the moon. And maybe 2021, 23 we get to man to the moon.
Yeah, we're going to the moon.
But it could be at least a 27-day trip. That's a long time. The longest trip ever we've taken is 18 days, and that was Columbia. When you think about the people living on the space station, it's their stay that's a long period of time. It's 5 to 6 months. But the travel time to the space station can be as simple as 6 hours, or it can be about 2 or 3 days. But everything that we're doing, we're trying to get to Mars. It is the closest makeup of the Earth. A couple little things that make it different. Temperatures are like minus 290 degrees. It warms up to 95 degrees Fahrenheit. Atmosphere is carbon dioxide, that stuff that comes out of the bodies. So there's a lot of things. Can we do this? I know the Martian movie had some little truths to it. There's a lot of questions to answer. So right now, the smartest thing to do, there's now 6 satellite probes around Mars steadying. Keep putting rovers on the surface. Viking lander started off in the 70s. Sojourner, Pathfinder, Spirit, Opportunity, Curiosity's been in the Neil crater. I'm not sure what they would call the next rover. Watch, not until at least 2020, they make those out in Jet Propulsion Laboratory in California. The Opportunity is still operational today. But there's a lot of questions. Can we do this? Can we not? We can. We're curious people. But it takes about 6-7
Yes, we
months to get
can.
there. A Martian year is more like 22 months, it says it's 12, and then it'd be 6, 7, 8 months back. So there's still a lot of questions before you say, let's go. But we're going to make that happen. It's just something that I hope it's still around to see in the future. That's a task that's attainable. Anything after that is not. We're going to Jupiter.
I love Jupiter.
You know, it's a big old gas giant with a solid coordinates. You can put on a gas giant if you can. It's got all these fast-moving winds on the surface. It has a 10-hour day. But Juno, actually, the probe that's there now, it took 5 years to get there, is steady Jupiter. And for our satellites, you know, they go around with our Earth's rotation and do actually this elliptic orbit. Or some of them go north to south into polar orbit, staying with the gravitational pull of the Earth. But you have a gravitational pull of Jupiter that is very, very strong. And if Juno was just kind of going around and trying to steady it, it would have already been sucked in and it would be gone. So it actually has to come in very close in a certain spot and come back out far and get away from it to a huge elliptic orbit and keep going around it since it's such a big race. It only takes about 48 minutes to get information back. That's not bad because it is over 1 billion miles away from us. Someday it's going to have done its job to let it crash into the surface of Jupiter. We don't have to worry about space debris. You know, the next planet next door is the same thing. It's a big old gas giant for Saturn. I wish I could put rings up there, really make it look cool. Always there's still this fast-moving winds on the surface. The probe that's there now is called Cassini. It was a 7-year trip, studying the planet, studying its rings. These 2 big planets really help us learn a lot. But there's still gas. You know, Jupiter takes about 12 years to orbit the sun, and Saturn's around 29.5 years. Both of these planets have well over 60 moons. So we're going to even go travel even farther away. We were kids, this was Uranus. Our NOAA guy come in and help us work put all this stuff together. This used to be down at the old Astronaut Hall of Fame. He said, Uranus. I said, what are you talking about? That's what you call it now. He said, you gotta be politically correct. I said, you're being no fun whatsoever. This is a big old ice giant. It's 14 times the size of the Earth. It's frozen water, methane, ammonia. It was discovered kind of way back, 1794, a man named William Herschel. But how do you set on a big old ice giant? 84 years it travels around the sun. That means we keep getting farther and farther away from the Earth. Neptune, another big ice giant, a little bit different. Still made of water, ammonia, and methane. Same stuff as Uranus. But it's blue because the methane is frozen instead of the water. All those little dark spots you see are storms and little white clouds we call the scooter. Neptune will not orbit around the sun until 165 years. This planet has 19 moons with it. Pluto is the farthest place we've been to. Over 3.5 billion miles. In the old days, we sent a probe there. The Viking probe took 20 years to get there. We sent New Horizons, that was a 9-year trip. When it's very clear here at the bottom, it shows nothing about Pluto. They say it comes from the Hubble Space Telescope. You're thinking, wait, the Hubble shows these really cool pictures here on the other side behind you. It can't show us anything about Pluto. I don't know, maybe because it's so close to the Earth. We have another telescope in work called James Webb. It's actually a U.S., Canadian, and European project. Looking, hopefully next year, to take off from Franchiana. It's 7 billion miles away from us. It's super powerful, 10 times more powerful than James Webb ever thought it would be. You'll probably be able to see Pluto. New Horizons, when it was starting to approach, started to give us this real fuzzy looking picture. And then when it finally got to Pluto, and this is a true definition of what it looks like. It takes about 4 hours to get information back. I guess it's not bad for a 3.5 billion miles away from us. And trying to call it that dwarf planet. This has a lot to do with what it's made of. Could have been a moon of Neptune that escaped, is one of the things that been said. And it wasn't discovered until 1930. And that's not that long ago, if you think about it. Well, we'll never be able to go there unless we can play Star Trek. You know, that's not possible. That's all fictional. There is another planet past Pluto they've seen. They call it just Planet X.
Star Trek's fictional? Since when?
I think they're hoping they'll make it out to that location. Maybe tell us more. Is it a planet? Is it a satellite? Really, what is it out there? Soon we're going to get there. Who knows? You never know what the future's going to bring. Got many generations still behind us on those sit down. Anybody have any questions?
Okay, Jimmy, you look good on the ground. Go ahead and
Our duct. Yes, it's really a smoothie.
Roger. Hey, congratulations.
Well, you couldn't have the thrill down there that we have up here. Passing Madagascar, leaving com range.
Roger, 8. If you run into trouble and the Gina goes wild, just send in command 400 to turn off and take control of the spacecraft.
Roger, we understand. Thanks, Jim.
I'm not hearing thrusters fire. Let's go to ACS off, comms power on.
We're going to spin and see a Gina. Send command 400, undock now. It's actually getting worse. Power the system off.
We have serious problems here. We are in the final left-hand roll at the present time.
The hand controller is locked up. It can't turn anything off.
Did I hear him say he may have a stuck hand controller? Roger, what up, Gina? No, he says he is separated from the Gina and he's in a roll and he can't stop
good idea, Major Glenn. It's gonna be a flat pack again.
Our fellow Marines need us to get this done. I'm going in.
Rock the bat.
Going low. I hit. Still have control.
Fire it. Good hit. There's not much left of your tail section.
Roger that. Let's see if I can make it back to base. Welcome to the Air Force, Major Cadet. What do you think about that new F-86 Sabre jet?
Well, I think we're about to find out. Ask me again after we take out these MiGs.
Roger that.
You have to remember my time of growing up in the 1930s. The people of the past, the barnstormers, and the people that did their early triumphs in aviation, and one of them, of course, was Charles Lindbergh. They asked me if I would sort of escort Lindbergh down on the beach watching for the launch of Apollo 11.
Over here.
It'll be a memorable flight.
Kind of like your first flight across the Atlantic.
The flight I'll remember most is your Apollo 8. The first flight to go around the moon.
Now we're going to land on that moon.
As I walked with my hero and looked up at that flaming candle taking off for the stars, it all came full circle. A spark of inspiration shaped my career, and my journey took me beyond my wildest dreams to places like the moon. We had just to turn that spark into a flame with the fuel of curiosity. To learn from our failures, never give up until the goal was reached. My heroes and their heroes before them were driven by this notion. So was the entire NASA team when they started this amazing journey into space. Our heroes and legends drive us into the future. Each generation inspires the next to go further into the unknown, beyond our solar system, beyond our galaxy. I can't wait to see where you will go.
Please remove your 3D glasses and watch your step as you exit the theater to your left. Please place your 3D glasses in receptacles located outside of the theater. Enjoy your experience at Heroes and Legends, featuring the U.S. Astronaut Hall of Fame.
There, but we just ran out of Wi-Fi. That was Heroes and Legends. Again, it's a 4D show, so most things need to experience because there's a lot of effects going on around here, as well as that's in 3D. So.
One artifact I didn't mention too, actually, are Wallace Sigma 7 capsule and Redstone. Redstone rock is actually ever since human rated Redstone found in the Science Station, the Atlantis station, all four versions. It explains that these two vehicles are actually together, even though they're both Mercury. Wallace Rise happens on a Mercury Redstone, but for artistic presentation. All the handwritten notes that were inside this movie all reference who they thought
system in New Jersey. I was exposed to a summer camp that had wonderful opportunities in Maine for exposing people to the close fellowship and associating with boys of age and
Concentrated so much on on this mission for so long, didn't think much about anything else, and then to have it over was really a big relief.
Everything was going so well that it was beyond belief that it could go that easily. The telemetry people noticed a signal which was indicating that the heat shield had come loose. We began to ask him questions.
Do I feel any bumping or something like that? So it's quite obvious they weren't telling me exactly what they were thinking on the ground.
Hey, Captain, on this escape flight, you want the astronaut to put the switch in the auto division. If he gets a red light, then we want him to re-enter with the pack on. He should, of course, get no lights at all. If he gets either a green or a red light, then we want to re-enter with the pack on. All right, that's it.